Today, what we are going to be talking about are two different things that sort of branch off of that. In fact, today, we should not have to do any factoring. Today, what we're going to do is we're going to be doing solving quadratics. I'm just going to call it quads for right now. By the first thing we're going to do is called extracting a square root. We've kind of already done it, but I want to make sure that you see it. Extracting a square root and then completing the square. Now, here's the thing. Completing the square takes a little bit. Extracting a square root, I think we can do super fast, and one leads into the other one. So what I want to show you, we've got like 15 minutes left. So you're not going to get a fantastic coverage of this. I'll probably have to cover a little bit more of it on Wednesday when we come back, but we'll get a good idea as to what we're going to be talking about. So here's the thing. Extracting the square root is kind of great because these are problems that are set up in such a way where you've got an x squared term and it's equal to another term like this. Now, y'all, let's see how much you've learned. Tell me, what does x equal? What does x equal in this case? I see. Now remember, it's squared. We're looking at this. You're not dumb. It's 4, and then we've got the negative as well. So we got to remember, you got a positive and a negative possibility for this one. We know that it's 4 or negative 4. Now, what we haven't been doing is writing the work for this. So the work, when you have something squared is equal to a number, you extract the square root or take a square root of both sides. And when you do that, you make sure that you include a positive and negative answer because they both have to be there as an inclusion. Here, the squared and the square root cancel each other out. Here, I'm going to have plus or minus 4. I'm done. Those are my two possible answers. Positive or negative 4, done. Now, that's easy to do in a situation like this. What you have to think about is what happens when you're dealing with an x squared is equal to 12. We can get an answer. It's just not a happy whole number. So if I take a square root of both sides of this, which once you've isolated the squared term, that's what you would do is take a square root of both sides. You include your positive and negative on the outside of that. And I do this here. You got to do that every single time. What we have to do is simplify from this point because the positive negative square root of 12, we still got to factor this, guys, remember, and see what can break out and what can't. So square root of 12, this can actually be, remember, this is 4 times 3. We know the square root of 4 is 2. So this is plus or minus 2 square root of 3. That's what my answer is for x. Now, how many of you with what I just did there have had, that's kind of a little bit of a shakeup. You're like, oh, yeah, no, I remember doing that now. I just wouldn't have done that off the top of my head. How many of you guys are like, okay, that's kind of okay. I sort of remember what's happening. How many of you guys are good with that? How many of you guys are not good with that? If you're good, say yeah or good. If you're not, we're definitely going to do some other examples, but say not if you're not good so I know where we're at. Okay, so here's the cool thing about extracting a square root. I love doing stuff like this. I think it's really fun. And, you know, it's helpful when you have things. I'm going to try to make this not god-awful terrible, but if I give you a problem like, here we go, 2x squared minus 7 is equal to 13. This would be something that you could solve using extracting a square root. You isolate the x squared term first, you take the square root of both sides, and then you simplify as best you can. If you can simplify the root, do it. If you can't, that's fine as well. So here's what we do. So I'm going to add 7 to both sides. We'll get 2x squared is equal to 20. I'll divide both sides by 2. I get x squared is equal to 10. And then if I extract the square root, we include our plus and our minus here. Great thing about 10, it only breaks down into 5 and 2, so there's nothing I can do. My final answer for this is that x is equal to the positive and negative square root of 10. And that's the thing, guys. What we're looking at right there, that's our deal. That's the way this kind of goes. Where this gets interesting is solving problems like this are lovely, especially if you've only got an x squared term and no just solid x, nothing I can do. I just do this and we're fine. I can't really factor this. There's not a whole lot I can do with that. Now, what I love is what's about to happen. So I'm going to give you a problem that we will extract the square root to get. First time I saw one of these, I was like, what? Okay. X minus 6 squared is equal to 9. Let's do that. Okay, now I'll tell you, the first time that I learned about anything like this at all, I was like, all right, so crap. I got to multiply that one out, get the whole thing on this side, then bring the 9 over so it's equal to 0, then factor what I have left. Then once it's factored, I can figure out what the answer is. And that totally would work. However, remember, if you have something squared equal to a number, we can extract a square root. And the reason why that's great is because I have something perfectly squared. Now, when I cancel this out, I'm going to have x minus 6 left on this side. However, it is going to give me the possibility of saying, well, I don't have to multiply that out. I can just cancel this one out and solve for x because I've included my plus or minus here, so I have more than one possibility accounted for. This will give me x minus 6 on this side. And on this side, I will have plus or minus 3. Now, we do have to take into account that this is two separate numbers. So that when I bring this 6 over to the other side, this is 6 plus or minus 3. That is two possible answers. One is the 6 plus 3 answer. The other is the 6 minus 3 answer. In this case, 9 is one of the things that would work for this. In this case, the other thing that would work would be 3. So we have two answers, 9 or 3, that would work with this type of problem. Now, how are you guys feeling about this? Does this feel manageable? Does this feel okay with you? Give me a yes if it does, so you let me know. Okay, so the other thing that I want to add to this is only that when you're doing something like this, if I give you a different problem that has, here we go. We'll go x plus 4 quantity squared is equal to the square root of 18. There we go. No, not square root of 18. Man, I almost swore at myself, like real swore, like used one of the real words. Glad I did not do that right now. I meant to be 18. Again, I'm a little tired. Okay, so again, you've got something squared. It's equal to a number. So if I extract the square root, just make sure you include your plus or minus. On the left-hand side, it cancels out the squared, so we'll get x plus 4. On the right-hand side, we've got positive and negative square root of 18. Because I can break this down some more, I have to. So 18 can be broken down into 9 times 2. And if I make both of those a perfect square, that 9, square root of 9 is going to become 3 root 2. Now, in this case, there's a lot going on there, but in principle, it's not any different than what I did up here with the 6 and the 3. It's just that I'm not going to have like terms to combine. When I bring this over here by subtracting 4, this does not combine with 3 root 2. This has a root, this does not. So this is going to be that x is equal to negative 4 plus or minus 3 square root of 2. And that is my two possible answers, negative 4 plus 3 root 2, negative 4 minus 3 root 2. Now, how many of you are familiar with the quadratic formula? That whole x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you've heard of that before, the quadratic formula, say yes. Okay. You guys, a lot of you have heard of this. If you notice our plus and minus, you notice this type of answer gets us into the place of recalling the types of answers you'll get with the quadratic formula. And right now, if you don't memorize it this very second, I promise I'm going to give you a song that'll have you memorize it, but it's not going to be today. What I want you to see is that when we get answers like this, these are because this sort of problem is unfactorable, but we can still get an answer to see what's going to happen. So this has irrational numbers with square roots along with regular rational numbers on this side. We got two possible answers. Just know this is what most of our answers are going to look like once we start to go through it. And Dominic, yes, it is Pop Goes the Weasel. Now, here's what I want us to do. I want to show you something that ties all of the everything together that we had talked about before. Now, generally, I build this up over a number of days. I currently have 8 minutes to get this one done. This is called completing the square, and it is awesome, but also crazy. So I want to make sure that you understand when I say square, those are the terms that look like this, like the x plus 3 squared. That's what I'm talking about. Now I want to show you something really quickly. We had talked about perfect square trinomials. When this one is multiplied out, we get x squared plus 6x plus 9. And so the part that I want to make sure that you see is this 3, if I double it, it gives me the 6x. If I square it, it gives me the 9. So this sort of problem is the sort of thing that we're going to see to get to a perfect square if we factor it. And the reason why I like calling them squares is because if you see this, what this ultimately becomes, if we look at an x plus 3 in a square, like actually written as a square, if they're the same thing on both sides, as a square would be if we're talking about the area of this, x squared, 3x, 3x, 9, these two things are going to be equal to each other if this is going to work, okay? And they're always going to be half of whatever this one right here is. Does that make sense to everybody kind of in general as to how something like this goes? Because what I'm about to do, you're going to go, what? And then it's going to all make sense, okay? What we're going to do to complete a square is I'm going to give you a problem that doesn't look like this yet, okay? I'm going to start off and I'm going to give you, actually, I'll use this exact sort of setup. So let me scoot this up a minute. I'm going to tell you, here's your new problem. It is going to look just like this. We're going to start with x squared plus 6x. Oh, let's go with minus 12 is equal to, let's just say 0. There we go. Now I'm going to tell you right now, there's no way to factor this. This is unfactorable, okay? And I'm saying that to you because I want to show you how we can actually solve this to complete the square. The great thing is that all that work that we did before that had things like this on it, where we had something squared is equal to a number, we should be able to make this set up in that format. Now I'm about to show this to you, and then you'll go, huh? And then maybe I'll show you another example, and maybe I'll have a little bit more time to do it on Monday. What I want to be able to do, I want to end up in a situation where I have something squared is equal to a number. So I can just take a square root and solve it from there. Problem is that this is not a perfect square. I know I would need a 9 to make something like that work. So here is how we complete a square. Your first step, if you have something like this, take whatever this constant is, because it's not a perfect square, and we're going to use the other side of this equation as like a holding zone. We're going to put everything over there so that I can make this left side into something that can be a perfect square, okay? So the first thing I'm going to do is I'm going to take that 12 and I'm going to move it to the other side. Plus 12, plus 12. This is my holding space, and what I'm going to do, x squared plus 6x, I'm going to leave some space here, equals a positive 12. And this is the reason I'm going to leave some space, because what I need to do, I need to make this into a square so that it's going to be something to work with. And so here's what happens. You guys ready? What I need to do is, in fact, complete the square. I need the number here to make this a perfect square to go here. Now, we know that that number is 9. We just worked with it. But I want to show you how to do this by looking at the box. Right now, what we have here is the upper left-hand corner, and I know that that 6x has to get divided in half to make this a perfect square. So I'm going to have a 3x here and a 3x here. This consists of everything that I've been given right there. Here's the great thing. I know enough about factoring these that I can say, okay, well, hold on. To get what I have here, these would both have to be x. This would have to be a 3, and this would have to be a 3. So to get it complete this square, what I would have to do, you ask a great question, Caroline, and I'll get to it in a second. What I would have to do to complete the square is fill this last box in with what it would have to be to make this a perfect square. Guys, tell me, what would our magic number have to be right there to make this a perfect square? It would have to be 9, yes, because 3 times 3 would give me 9. I have now, with this 9, completed the square. However, that 9 didn't exist before I put it in this box. So to be able to make this work, I have to put this 9 right there. That's the part about this that's great. It's an equation. I can introduce something to this side, but I got to do exactly the same thing to the other side of the equation. And if I do not, then I have not followed the rules of math. I completed the square. I've now added that to both sides. What that means is that the left-hand side of this equation is now this perfect square, x plus 3 quantity squared. This right-hand side, if I add that 12 plus 9, is going to give me a 21. And look, I now have it in the format that I wanted. Now I can extract a square root and solve it. So I'm going to really quick finish this problem by taking a square root here and there. There's my plus and minus. I will have x plus 3 is equal to plus or minus square root of 21. I'll tell you, the only things that go into this are 7 and 3, and neither of those are perfect squares. So that's where it is. Now, if I subtract the 3 from both sides, I can tell you that x is equal to negative 3 plus or minus the square root of 21. Now, Caroline asked a great question that I want to call out to everybody. What if this is odd? Can you still divide it in half? You can, but now you start to deal with fractions. And it's fine. That's actually what helps us lead to how we get to the quadratic formula. You can absolutely do that. You can even do it with numbers in front here. They're just really ugly, okay? And so somebody asked if they could write the square root of 21 minus 3. The one thing that I wouldn't want to do with this when I'm looking at it is the reason why I generally tend to not do that. So if I do the positive negative square root of 21 minus 3, some of you guys have what I'm going to call a strong hand with your square root. The more that I write this, the closer and closer that gets to covering this up and not knowing whether that 3 is underneath or not. I always put that negative 3 in front because I want to make sure that there's not going to be a question as to whether that is combined with the 21. So that's why I put it front. And I will tell you that almost all the time, that's what you're going to see with math books and math teachers from this point on. If you wrote it, you're not wrong, but you may want to correct that, okay? Now, here's a question. Actually, it's not even a question. What I'm going to tell you is this. We've only got our last minute here, so I'm going to stop sharing and say to all of you guys, that was a good introduction to what we're doing here, but we're going to have to do a little bit more work with this. I'm going to talk more about it on Wednesday when you guys come back here, but I did want you to at least see the beginnings of this. So I'll give you a little bit of ins and outs of what that's going to look like and lead to the quadratic formula on Wednesday. Again, let me know if you're not going to be here on Wednesday for some reason or another, but please finish the quizzes that you need to do. Are there any questions before I let you guys go? Okay, guys, have an amazing weekend. Happy last Friday of the year. See you on Wednesday of next week for our last 2 days of class. Good to see you all.